Hey guys, today we'll be talking about techniques in developing well-written code. So first up, it's me talking about the use of good programming practice, and my first point is for a clear and uncluttered mainline. So your mainline is pretty much just a collection of all of the modules that your program has, and it will run through and run each module in the order that it's supposed to, like chronologically, and it'll determine when they run in what order, as well as any loops and other anomalies in the module. So it'll just go through and run pretty much the entire program. Second point is to have one logical task per subroutine. Subroutine is a set of instructions to perform a frequently used function within a program. These routines are separate from the other modules, and they may be called on by these to perform the function, eliminating the need for repetitive code in the program. So a good example of this is collisions in a game, where throughout many other scripts there will be a call line to run the collision script. So it's got the main line here, and the main line will call to the subroutine, and the subroutine will return to the main line. So it will run the subroutine code and then run back through the main line. The second point for the use of good programming practice is the use of stubs. So a stub basically is intended as a stand-in for a module or subroutine of a program. The stub will not run the module's original functionality, but is used to test whether the code of the original module is dysfunctional, or to test the other sections of the code with no real consequences. In this example, the stub is being used to test the average grades code. So where it is sourcing the average of the grades in a cohort, but is using a stub of the actual grade system to test the average grades mechanic without actually using the values. The next point is the appropriate use of control structures and data structures. So here we've got data structures and their definitions. So an integer is in whole numerical values, so 1, 27, 4,583, and etc. And then a string is text values, so pretty much any assortment of text, or they can be numerical values as well in a string. Then there's the floating point, which is the decimal place, and that can be placed anywhere within an integer. So there's like 1.2345 and 12.345, and etc. And then here is a boolean that is a binary true or false, so that's and or not. And here is an array that is a collection of values that are stored and can be called on in separate or collectively. And then there's also a record, which is a collection of data stored for use by a program. So continuing, we have the control structures, so algorithm components, and that's the shapes and their meaning. So firstly, we have the circle, which is the begin or end of an algorithm, and the example is for like begin player health. Then we have statement blocks that give instructions, and these will go down through the algorithm, and they're probably your most common ones, and that's, for instance, player health minus 10, which will make the player health variable negative 10. And then we've got the diamonds, which are decisions within an algorithm, and are typically binary yes or no outputs. So if player health is less than 0 is an example. And here we have the arrows that dictate the flow of data in an algorithm. So the next point is for version control and regular backups, and pretty much this is just so if anything goes wrong with corruption, hardware failure, software failure, anything, there'll be backups to go on, and also version control has a clear kind of representation of your progress throughout the development of a program. So here we have the major updates, so that's for instance, from 0.5 to 1.0. For completion or major overhauls, so remakes of mechanics, visuals, etc. Pretty much from version 1.0 is a fully completed game, and from 1.0 to 2.0, it'll be a whole new game. Then we have minor updates, so for instance, version 0.5 to version 0.6, and that's for major updates within the program, and that's for instance like a new level, new mechanics in a game. And then there's also revisions, so from 0.5 to 0.5.5, and that's for very minor updates and revisions such as bug fixing and refining and etc.
Yeah, so in the process of coding, errors are bound to happen to a program, whether it's during the process of debugging code or coding. Some of the errors that would be detected in this process in syntax errors, logic errors, and runtime errors. Syntax errors are a type of error that occurs within the source code of a program. This error happens when the language is misused. When this error has occurred, it prevents the program from being debugged or complied. It will not comprehend the given task. This error happens when something has been entered into the program by the user or the programmer that is invalid and unsolvable by the program. Due to this, it cannot do anything else but display a syntax error. This type of error is a human error and is not a mechanical one. A common syntax error that happens is when you are using a variable and it has not been properly declared yet. Variables need to be declared for it to be recognized and registered within the coding. In this example, the variable number is shown with an error as it hasn't been declared. Another example is where the operator such as an integer, boolean, and string is misused, such as incorrectly converting an integer to a boolean. The final example for the syntax error common seen outside of programming is where the calculator is on a calculator. So let's say you type in 12 plus divided by 3 and then press enter. A syntax error will come up as the user has inserted two symbols that do not work together. This is a common human mistake that people make when doing this. Logic errors are a type of error that occurs within the source code while it is being run or executed. When this happens, the programmer will be producing incorrect behaviors and which makes the incorrect outputs, leading to the application crashing. Even if the programming is valid, it will not behave as coded. The logic error is the difficult to spot as the coding is written fine and therefore cannot disclose the problem to the programmer. The worst result for a logic error is the crashing of the computer. It is hard for a program to detect as it will come up as a valid statement within the code but will have a different meaning. An example of this will be using the incorrect number of equal signs, such as equal refers to as is equal to, while equals refers to as while. Another example would be using the less than operator when it should be the greater than operator and vice versa.
Okay, so runtime errors. Runtime errors refer to the errors which take place whilst the program is being executed. They occur as a result of the program understanding what you have coded, but then runs into issues while executing the program. They're commonly referred to as bugs, often occur during the debugging process. Time errors can be fixed by ending the program or stopping each running program one by one and checking to see if the errors reappear. One type of runtime error is a memory leak, which causes a program to take up more RAM space while the program is being run. They're commonly the result of an infinite loop. Arithmetic overflow. It is a condition that occurs when a calculation produces a result that is greater than a given register or storage location. A carry occurs when the result of an addition or subtraction does not fit in the result. Therefore, carry flags are checked during these calculations. An overflow proper occurs when the result does not have the sign that one would predict. For example, negative results from adding two positive numbers. Therefore, it is useful to check the overflow flag. There are several methods of handling overflow: avoidance and propagation. Avoidance is carefully ordering operations, checking the operands in advance and selecting the correct data type. Propagation is if a value is too large to be stored, it can be assigned a special value indicating the overflow has occurred, and then have all successful operations return this flag value. Computers are mathematical machines, and divide by zero is undefined in Boolean algebra, which defines the machine's hardware logic, and the machine is designed to react accordingly. This can result in crashes or incorrect program output. This issue can occur if a software is being run on a computer that is hardware that is incompatible with the software to solve this. To solve this problem, make sure all software installed on the computer is up to date and fully compatible with the system. If the divide error happens while in a game or a program, verify all software patches and upgrades have been obtained and applied. If you write past the boundaries of a variable, the computer will do what you say, but it will end up corrupting another memory location. On a system with protected memory spaces, for example, a Microsoft 98, this sort of statement will cause the program to terminate execution of the program. On other systems, for example, Windows 3.1 or the Mac, however, the system is not aware of what you're doing. You end up damaging the code or variables in another application. The effect of the violation can range from nothing at all to a complete system crash. C and C++ do not perform any sort of range checking when you assess an element of an array. It is essential to pay attention to array ranges and keep within the array's appropriate boundaries. Error is a condition when the output information does not match with the input information. Whenever a message is transmitted, it can get scrambled up by noise or data that may be corrupted. To avoid this, we use error detecting codes, which are additional data added to a given digital message to help us detect if any error has occurred. Examples of error detecting code is parity check or two-dimensional parity check. So what a parity check is? A parity check is the simplest technique for detecting and correcting errors. So in this picture, this is a 8-bit data, which the first one is considered as a parity bit, and the rest 7 are the other variables in the actual bit. The parity can either be an even or an odd. So in an even number, that just refers to how many 1 values there are in the whole parity. So in this first picture, there are 4 ones. That means that it's an even parity. So in an odd parity, there will be, for example, 5 or 3 difference. So in the first one, there are 5 ones, so that means it's an odd parity. Parity check at the receiver can detect the presence of an error if the parity of the receiver signal is different from the expected parity. This means that if it is known that the parity of the transmitted signal is always going to be even, and if the receiver signal has an odd parity, then the receiver can conclude that the received signal is not correct. In this example, the first one, that the transmitted code, is an even parity as it has only 4 ones, but the one that's received is the odd parity, which has only 3 ones in it. User flags. If the programmer wants to check a certain part of the code is working, they use flags so that a certain part of code is bugged instead of the whole code. It usually acts as a Boolean variable indicating a condition to be either true or false. This is determined by detecting errors and problems within a code. Flags are used to control what is being executed and debugged. It is used as a checking point. For example, the loop will break when 1 equals to 100 in this example. A logic error is a mistake in a programmer's source code that results in incorrect or unexpected behavior. It is a type of runtime error that may simply produce the wrong output or may cause a program to crash while running. The logic error might be noticed during runtime because logic errors are often hidden in the source code. The programmer may use a comment tool to stop code from running. Programmers may also comment out blocks of code and systematically find the precise location of an error. Multiplying 2 numbers instead of adding them together may also produce an unwanted result. Debugging output statements are temporary lines of code added to display the value of a variable. Displays variables at various stages in the code. It may also be used to state that a particular part of a code has been reached. Outputs are used as part of stubs. Stubs track the number of times a subroutine has been executed. The programmer views raw data before it is being processed, which allows a programmer to localize and fix these errors. This involves the checking of the code along with other programmers. Peer checking is useful as it allows better ways to overcome obstacles and find solutions to a problem. The end result is that both developers are fully aware of the code, how it works, and why it has been done that way. Chances are the code is better than one developer that is working alone. It is less likely to contain bugs and hacks and things that cause maintenance problems later. Test data is used to compare the actual results with the expected results. Use structured walkthrough to step through the code and find what error occurs. Desk checking data may be performed on subroutines and whole programs. Desk check is a process of manually reviewing the source code of a program. It involves reading through the functions within the code and manually testing them, often with multiple input values. Structured walkthrough are more formal than peer checks. No attempts is made to correct problems as they stand, but instead of get feedback. This is made to evaluate the design at different levels. This saves time and money as defects are found and solutions to these problems. This provides value-added comments from reviewers with different technical backgrounds and experiences. It creates awareness about different development or maintenance methodologies that can provide a professional growth to participants.
So breakpoints, otherwise known as a pause, is detectable in the duration of debugging the written code. Breakpoints are known for the intentional stopping or pausing of the program. While the code is being executed, all of the contents will be running, and when the breakpoint is reached, a temporary halt will occur in the program. These are used so that the program can be tested and examined in intervals, or to test if a program stop will happen at the right time. An advantage for using a breakpoint is the shortened time for the overall debugging process in a large program. Breakpoints can be set at any line of executable code. A C# example includes the setting of a breakpoint in the variable declaration, a for loop or code located inside the for loop. A breakpoint cannot be set in the namespace, class declaration, or in the method signature. If a breakpoint is being set on Visual Studios, it will be indicated with a red dot on the very left side of the code. This is shown in this photo where it has a breakpoint inside a for loop. During the time a program is running, the stored value within a variable can change. The contents of a variable can be changed so that the value stored can be printed and have the coding to determine if it is being properly processed and accurate. An example for where this is useful is for the use of complex mathematical equations. So if the used variable are encoded to be simple to work with, the calculation for the equation will then be carried out. By doing this, it makes the process simpler for finding bugs. Program traces is the viewing of a progression of the program in detail. In Visual Studios, it will allow the program to put in a log message onto the main output window and is only seen when the program is being debugged. A program trace is a specified string argument that can have an unlimited amount of variable arguments. Program traces are usually set for following the process of the program within a nested loop, which is a loop inside another loop, and finally, other complicated sections of the program. Here in the first example, we have a trace test void and a program trace where it's being called, where it says trace bracket underscore t bracket, and then the string trace testing with it closed with 2 brackets after it. In the second example for trace test 2, there is a character class for maths, English, and history, and the integer set for the number of classes to equal to 3. By having this, it will say, hello, you have 3 classes today, history, English, and maths, in the log message as the coding shows the program trace caller. Single line stepping is the tracing of variables where it enables the programmer to recognize the value of variables when they are changing throughout the process of execution. Single line stepping allows the programmer to view every single line to ensure that it is being executed correctly. The variables which have the values which have the variables stored in them can be traced as well throughout the flow of the program. To have this done in Visual Studios, the debugger needs to be attached and then press F5 to begin debugging the program. While this is debugging, the next line of code will be executed is highlighted in yellow, as shown in this photo.